This is the next item for solving homogeneous equations. And yes, we have shown that this equation is already a homogeneous equation. We have a video for that, so please try to review that on your own time. This video will just comprise of the process involving in the solution of this homogeneous equation. Once we are sure that an equation or a differential equation is a homogeneous equation, the next thing we need to do here is to use the process of substitution. And with that, we are going to use a certain representation for either we have x or y variables. It depends on us which of the two will be used. But of course, we are going to introduce another variable. So x might be equal to, let's say, vy. We introduce here a variable v so that we could represent x in terms of y. Or we could also have y is equal to vx. It depends now on which of the two will be used here. Now, supposedly the first hint we used on our previous two videos on solving homogeneous equations is the idea that we are going to use whichever of the two where our dx and the corresponding dy will have simpler expressions. But here, both of our dx combines to have or shares binomial quantities or binomial expressions. So we cannot really say that one is simpler than the other. Of course, they only differ with this next terms, but we can't really say that one is simpler than the other. So let us use y here in terms of vx. So this expression will become equal to our expression where it only contains x. So that this would be simpler, okay? Well, we can also do that here, but since it's second degree, so we could have exponentiations, but let's have it like this here. So what we could do is to substitute or choose this process substitution, which also involves the change of dy. So when we have y is equal to vx, the first derivative or dy is equal to the derivative of the product. You can have here, you will have v dx plus x dv. That's how we take the derivative of a product. So we're going to have here the same expression, x squared plus y squared dx plus you will have here x squared minus xy dy is equal to 0 here. So we simply substitute y to vx, so we can have it like this here. Of course, you could also try this other form, but we're going to suggest to use y here in terms of x. So substitute that both in this form. So you have here x squared plus your y, which is vx, so the square of that, okay, dx plus x squared minus x times y, which is vx as well. And your dy is now this form here, v dx plus x dv. Okay, now since what we can see here are only v's and x's, so we simply need to simplify all of these terms. You will have here x squared plus v squared x squared, that's for dx. Here you will have x squared minus vx squared times again v dx plus x dv. Now let's distribute all these terms. So you have here x squared dx plus v squared x squared dx plus x squared times v dx plus x squared, but that's already x cubed. I'm distributing x squared first. Yeah, of course you can also use here the FOIL method, but I'm just going to use it like this. So x cubed now, x cubed dv minus you will have v squared x squared dx plus minus vx cubed dv. Sorry, they're all equal to 0. I forgot to place equal to 0. Again, this was the result of this. Okay, this was the result of this. Let me erase this. This was the result of this too, x squared v dx. Then this was the result of x squared times x dv. Then minus vx squared times that is this one here. And then minus vx squared times that is this one here. All equal to 0. We're doing this because we can see some items later that can be simplified. So we can remove that. Okay? So by removing that, we can have here x squared dx plus x squared v dx plus x cubed dv, then minus vx cubed dv as well equal to 0. Okay. The next here is to group those with dx and those dv, and if possible factor something else if we can. So we can factor here x squared. You will have 1 plus v, then you will have your dx. Take note, I am factoring dx to our left. I'm also factoring x squared to our right. Or if you don't want that, and if it's difficult for you to follow, let me do it again. I'm only going to factor dx first. So you have x squared plus x squared v, and you have dx. And this time, I'm also going to factor only dv. So you will have your x cubed minus vx cubed, and you will have your dv equal to 0. Now, we're going to factor x squared here, x cubed here, because it has also the same. Because the point here, the next point here is actually to come up with, what do you call this one? To come up with a process of separation of variables, okay? So we're factoring here x squared. You will have here 1 plus v dx. Here, as I factor x cubed, you have 1 minus v dv equal to 0. Okay. Now, the next thing is separation of variables. We would like only v's for v and x's for x. So remove this, remove that by a certain process of multiplying a certain expression, a rational expression to our entire form. We're going to multiply a rational expression. To remove this, we're going to have x cubed here. Okay. So that x will only appear on the other side. And to remove this on this side, we also have here 1 plus v. So with that, the first term, we can already cancel this, and you have x squared over x cubed. So basically, that's just 1 over x. 1 over x, so that is x over x. Again, this would be canceled. X squared would be x cubed, right? Cancel that. So 1 over x. And since you have dx there, so you have dx over x. For our second here, x cubed will be removed. And you will have the form of 1 minus v over 1 plus v dv. So we have separated now our variables. Hey. Now, if you don't like this form here, you can of course always rearrange that. You will have dx over x. You can factor a negative item here. So you have negative, or we're going to take out negative. So the v will become positive, and the positive 1 become negative 1. Over, you can rearrange your denominator because we would like to see something like this on our process later. Okay, this is now the latest form. And then, we're going to, these are now, our variables are now separated. So we can now integrate both sides. Dx over x minus the integral of v minus 1. Okay, time v plus 1 dv equal to 0. Of course, we know the result of this because that's just simply the natural logarithm of x. Okay, plus c, but that's not just right plus c later. And of course, we know the result of this, which is just dimension c. But the item here is this. This is the biggest question right now. So what I would like you to do is this one here. Before all of these answers, this here expression, let me take that. V minus 1 over V plus 1 could be transformed into other expressions where it's also equivalent to that. You will have here, you can actually write it this manner. V minus 1, your numerator, can be represented as V plus 1 minus 1 minus 1. Okay? Because you're adding here a certain expression which is just equal to 0, right? So we're adding that. Okay? Take note of that. We are just adding that, but it doesn't change the entire value as we're just only adding 0. So this is still over V plus 1. So our numerator could be written as this, V plus 1 minus 2 over V plus 1. We are trying to do this because once we separate our expression into two different rational expressions, we'll have V plus 1 over V plus 1 minus 2 over V plus 1. We can rewrite that as to 1 minus 2 over V plus 1, which is easier to look at than this, and easier to integrate than, again, mentioned this. So we can rewrite our form here. dx over x minus the integral of 1 dv. Then since we have minus and minus here, two negatives, again this negative and this negative here, so the next form is plus 2 the integral of 2 v plus 1 dv. Notice that I have placed dv's here because they are all under the same expression. Okay, so the x is equal to the integral of 0. This time is easier for us to integrate this. So again, this is the integral of, or the result of this is the natural logarithm of x. Then here, just v itself, okay, minus v. You have here, you can take out 2 earlier. So you can have 2 plus 2, and the integral of 1 over v plus 1 dv is just plus times, because that's twice the natural logarithm of v plus 1, and then is equal to c here. Okay, so that's what happens now. Okay, now take note that we are assuming that the x in our logarithm of x is greater than 0, and the v plus 1 in this form is also greater than 0. Then we can actually represent our final form in this manner. You have the natural logarithm of just x, okay? No need for the absolute value, minus v plus twice the natural logarithm of v plus 1 equal to c. Let me take this on another page because I don't have much space here. Let me copy this because we are going to proceed to our next page. Okay, just like that one here. And before I continue, let me return to my previous page because we need to really be anchored with this, because we are going to return to our value later on with our y, because here we don't have y anymore. We represented y in terms of v, just like in this form, and we will be returning to that later. And let me just continue here. Of course, by the laws of properties of logarithm, you can have here the logarithm of x minus v plus the logarithm of the square of that, because it's the power of what they call this one, property for a power of logarithm is equal to c. Okay, now since we have these two, let me take away this one, the natural logarithm of x plus the natural logarithm of the square of v plus 1. I have here minus v is equal to c. Okay, if they have another property of logarithm, the sum, so you can rewrite it into 1 logarithm of x times the square of v plus 1. That's the product property, minus v is equal to c. Okay, so next is to introduce the exponentiation of both sides. So logarithm of x v plus 1, the square of that minus v, okay, is equal to this form here. Okay, but this is not yet simplified. You can take another represent it with another value later. Let's stick with that. But other references also would like to introduce here another step. This is what they did. C is just equal to natural logarithm of c for any arbitrary c. Okay, so since this is a constant, so this is also a constant here. So basically, from this step alone, instead of c, they are now introducing natural logarithm of c, so that when we go to our next step here, we can simplify this as natural logarithm of c, because this will be simplified, right? But again, if we stick with e to the power of c, you can always represent it with another arbitrary variable c, and we will just return to our process. So those are the two steps, but let's just stick with this because it's the common step. So we have here, since it's on a difference of exponents, again, you can actually result it into a exponentiation. You can have here a rational expression. So you have here, we can look at like this, v plus 1 squared over e to the power of v. Okay, or if you don't want that, simply just multiply e to the power of negative v, separating them. This is e to the power of natural logarithm of c. So again, with that, you will have x, v plus 1, then you have here times e to the power of negative v is equal to c. Now, what was our v earlier? Going back here This was our representation earlier. So y is equal to vx. In short, v is equal to y over x. So v is equal to y over x. Substituting it here. Y over x plus 1, the square of that, times e to the power of negative y over x is equal to c. Okay. That's our form here. So, of course, if you're going to apply here, or combine this rational expression, you have here y plus x over x and the square of that, right? Times e to the power, again, of minus y over x is equal to c. We're doing this because we can actually use the exponentiation here just to combine this plus x. Sorry for that. Okay, over x squared times e to the power of minus y over x equal to c. So their final form, you will have here the square of y plus x over x times e to the power of negative y over x is equal to c. Or if you don't want x here, you can multiply both sides by x. So your final answer, rearranging this as well, just for the purpose of illustration, x plus y squared times e to the power of minus y over x is equal to cx. And if you don't want this here, another step you could do, multiplying both sides by the positive, because you don't want, if you don't want negative exponents for our e, because with this and that will be cancelled. So you have x, or the square of x plus y is equal to c x e to the power of y over x. This is our final answer in a more simplified form of our item. So we used here these processes and these concepts, introducing again the logarithms and exponentiations, and going back to our original form. This was this homogeneous equation, which is a little bit longer and complicated because we have here expressions which are also complicated in nature. Thank you very much for watching.